All right, so we've got everything labeled in terms of currents. And let's do node A. We would have, I'm going to write it first, entering minus leaving equals 0. So that would look like IA is entering minus I1 minus I2 equals 0 because it's KCL. It's a conservation. All right, I could write entering equals leaving. I would have said IA entering equals I1 plus I2 are both leaving. And I'll leave off the other two for now because they are more useful in nodal analysis. But these are probably your main two that you're going to consider right now with just KCL. So either one of those is fine. You can see that the math is going to come out the same for both of them. So give a try to writing an equation for node B. And then check with somebody around you, double check what you've got. And then if you agree on that one, go on and do C, D, and E. And then we'll see what everybody's got.
Because it doesn't when I'm using KCL, it's entering and leaving nodes in this one. So it's because this whole code is like, it's the same thing as if this is the same as if you're connected to this. So if this is a node, this is a node, assuming the resistor values are the same, these are the same thing. So all this is just a way to draw it more nicely, I guess. Everyone likes the rectangles. So rectangles are usually this can be written the diamond can be written as a square instead also. Yeah.
Okay. So looks like the shoulders that I looked over looked like you had things pretty well organized. Couple questions that came up were about the sources. So like this current source, it comes with an arrow in the middle. And so I extended that arrow up towards node A because that's where I was starting. But it also applies to node D. The current has to come back and return to that source. Likewise, with the voltage sources, our sign convention said, well, the current has to leave the plus terminal. But that also means there's current entering the negative terminal. Right? So it's perfectly fine to draw the arrows on both sides of every circuit element, if that helps you. If, like the same thing with I2 through resistor 2, we could extend that arrow and bring it down to node B, if that helps us. And I5, we could draw everything at each node. So to begin with, I encourage you to over-label your drawings. Draw them big if you need to. You're going to only put your answer into Wiley Plus, right? So no one right now is going to see your work that you do on your own. So draw the pictures big, over-label everything, get the hang of it. In a couple weeks, you'll be able to do equations like this just by looking at the diagram. You won't even label stuff, all right? But until then, we want to overdo it and mark up as much as possible. The other thing I'll say about the sources is this independent voltage source, for example, would have a fixed voltage VB, and the amount of current depends on the circuit that we attach. So there's always both current and voltage with each source. Right? Same thing with this current source. It's going to have a fixed current that it produces, but if we were labeling voltages on the whole thing, we would also add a plus minus for that source. Right? It has a voltage, we just don't know what it is until we solve for everything. So you ended up with 5 equations, and if we knew the source IA, how many unknown currents do you have? We would have to solve for each of the resistor currents. So that's 5 currents. And the voltage sources, we know the voltage, but we don't know their currents. All right, so we would really have 7 unknowns for these 5 equations. So we would have to either have some other information or write some additional equations to help us with our unknowns.